Hi, and welcome to Csit 301 Mobile Application Development. This is session 12, and in this section we want to be talking about location services. Location services in WorkLight provide mobile application developers with the opportunity to create differentiated services that are based on a user's location. So based on where your user is located, you are able to actually serve them up with different aspects of your application. Now, in this session, we seek to explain the architecture of the location services and describe the APIs that are used to implement the service. At the end of this session, every student should be able to understand how location services work, use geolocation and triggers in a mobile application. The key topics to be covered in this session are as follows. We'll talk about location services, we'll look at the overview, and then we'll talk about something called the acquisition policies. We'll now talk about triggers and events. Then we'll see how we can create and test hybrid applications. As usual, all the materials that are needed to support this session have been uploaded onto the Sakai. Do well to have a look at them. And also the lab sessions, do well to go through them. Now, location services execute actions that are based on a user location. So geolocation coordinates must be constantly polled to establish mobile device location, because if these services are supposed to get executed based on a person's location, then we need to be tracking the user's location at all times. So this is how come we are always pulling or keeping track of geolocation coordinates. Now, WorkLight can handle multiple geo modalities. We have the GPS, we have the Wi-Fi sampling, and then we have the interpolation. The location services are currently supported on hybrid Android, iOS, and Windows Phone 8. Geolocation makes it possible for business actions to be triggered when users reach a point of interest, enter or exit a region. So based on the user's location, when they reach a point of interest, let's say for an example, you are running a restaurant, and you are running a restaurant in a particular locality. So when users enter that locality, let's say they have your app, when they enter a locality where a branch of your restaurant is, you could actually begin to prompt them with the menu that you have available, and that could get somebody interested, even the directions and all of that, and they could quickly get into your restaurant and go and get something to eat. So based on the point of interest, you can now begin to trigger some events. Now, when they enter or exit a region also, you can also do that. So with WorkLight, we are able to monitor when they exit a region or enter a region. Now, it can execute server-side logic to correspond to important geo events. So the geolocation, using that, we can execute server-side logic to respond to important geo events. It works on native iOS apps, works on native Android apps, and the hybrid Windows Phone 8 apps. So for an example, and like the example I gave, a fast food outlet could start preparing food for a customer as based on data that is collected regarding the customer's geographical location, so that the food is ready at the moment the customer arrives. So you are able even to tell how far the customer is, and if they placed an order, the moment they enter into a particular region, which might be maybe say 200 meters, 400 meters to your restaurant, you can begin to now package and serve their order. So by the time they get to your place, easily they can just come and pick up the food. We'll now look at the architecture of the location service. Okay, so we'll focus on the device for now. Now, the device has location APIs to determine where it is. So most of the phones, sophisticated phones that we have now, very common, they come with some means or API for us to be able to determine where the user is currently located. And when we gain that information, we are able to set acquisition policies. These are pieces of code that help us achieve some particular aim. We are able to set triggers, transmit events, and trigger callbacks. Now, on the server side of the architecture, the events and the device context are passed to the server. So the device receives all of that and ships it to the server. Now, the server will set event handlers. It will get the device context and set an app context. Then it would also process event callbacks. Okay. So we'll now talk about acquisition policies. An acquisition policy is an application code on the mobile device that controls the collection of data from device sensors. The collection of this data is referred to as the device context. So the data collected is what we call the device context. When a change occurs in the device context, which is the data collected, triggers can be activated. A callback function can be called. An event will be sent to the server. Now, to set up an acquisition policy, we would use the WL.Device.startAcquisition API. Now, that begins the acquisition process for GPS and Wi-Fi sensors. So when a new sensor information is acquired, the device context is updated and the specific triggers are evaluated for activation. Setting up the policy, we need to specify what we call the geo policy with the WL-Device geo profiles. So here we have 3 of these that we can set up. We have the live tracking, which is accurate positional information by high power consumption. So when we set it to live tracking, that means that constantly and periodically, very frequently, we are polling the user's location, and that could consume a lot of power. And then we have rough tracking. Now this is less accurate positioning, but it has better power management. That means that the interval at which we try to find out where the user is located is a bit lengthy than that of the live tracking. And then we have the third one, which is the power saving. Now this is low accuracy. Let's say it could be it will check for the user's location once every 15 minutes. So in 15 minutes, the user could move at a very fast pace. If you're in a vehicle and we are checking every 15 minutes, you could move even from one town to the other. But that provides good power management because the devices or the sensors are turned on and off. So we have here some code as to how we can set all of these. And here we can see that it's been set to live tracking. Now the polling interval is defined in milliseconds. So the polling interval is that interval with which we are going to be polling your location. The access points can be filtered. So we can have that also in there. So in this example, you can see that we have net 1 and net 2 as the access points that are filtered, and some with their MAC addresses. Now, permissions for acquisition policies using Android are set in the Android manifest.xml. So for Geo, we have the access cost location, and then we have the access find location as parameters. Now for Wi-Fi, we have access Wi-Fi state, and then we have change Wi-Fi state. So you need to add the following to the info.p list if you are trying to achieve a similar thing on the iOS. So here you have some details of what you need to add to the iOS to get it working. Now when location services are running in the background, with the iOS you can use the UI background mode to actually be able to get that. And this slide now is telling us, showing us how we can set the policies for a Windows phone. So here permissions must be set in the WM app manifest.xml, and for location services that are running in the background, we replace the default tags details with this code. So this piece of code will help you if your location service is supposed to run in the background. So now we are looking at an example of how to set a policy. Here we have an event listener, which is checking the battery mode, putting it in the power saving aspect. If it's power save mode, then the acquisition policy gets triggered and changed to a power saving, and then we have the settings for the power saving being used on that acquisition policy. Now we want to talk about triggers. Now the trigger object is passed as the second parameter to the start acquisition method. So our start acquisition method takes the policy, the triggers, and the on failure. Now the trigger holds definitions for all sensors in this format. So if for Geo you put that in, and then for Wi-Fi you specify that also. Now these objects hold key value entries that define triggers in the form of name definition parameters. So these are the various trigger types that you can have. For Geo, we can tell when the user enters a particular area. For Wi-Fi, we can also tell if the user enters, or we can track when the user enters. For Geo and Wi-Fi, we can track when they exit. We have dwell inside, that's when they remain in a particular area. And then we have dwell outside. Both for Geo and Wi-Fi, we can tell whether the user still is in a particular vicinity or location. And then for the Geo, we can call on the position change trigger. So we have the position change trigger. That is not actually the same in the Wi-Fi. On the Wi-Fi, is visible access points change. So those are where the differences begin to come in. And then for Wi-Fi, we have connect and disconnect. But for Geo, we have nothing like that. So we have more of the trigger types for the Wi-Fi than we have for the Geo. And we have 4 of them in common. That is the enter, exit, dwell inside, and dwell outside. Now this is an example showing how you can actually set the parameters of a trigger. Here we have the type being set to enter, and then we have the longitude, latitude, and then the radius. And then we have a callback function, and then the type of event to emit. Okay, so now we'll talk about events. Now events are created in 2 ways. A trigger is set up to reach some situation. When the situation occurs, the trigger creates an event and sends it to a handler. Then the WL client.transmit event accepts that event and then quickly processes it. Now an event object is added to the transmission buffer. The event object is either transmitted immediately or according to the transmission policy. In the adapter, we create a handler as follows. So the first one we saw is events on the client side. Now on the server side, if we want to have that, we need in the adapter to create a handler as follows. So we'll use the WL server.create event handler API, and then we pass in some parameters. The events that match the filter are passed to the handler function, and the filter examples are displayed here, so we can see some examples of what the filter would be like. And then we'll need to register the event handlers by using WL server event handlers. So that's how we would register events on the server side. Now we'll look at how to create and test a hybrid application. So in order to test an application, the triggers and error handling logic must be evoked. The mobile browser simulator, another component in our worklight, provides capabilities to simulate sensor data and errors. So we run the simulation on Chrome or Safari, and the widgets do not display well on Internet Explorer and or Firefox. So from the mobile browser simulator, we can get access to the geolocation widget, and we can see a snapshot of that, and then we can use that to trigger some particular scenarios. Then also we have the network widget. Now the network widget can be used to provide network information, for example, information that is accessible via the WL.Device get network info. So we can use that also to get and edit these info. Then finally, the last widget we can use is the scenarios widget, which we can use to define scenarios to simulate a trajectory for a device. So in a case where we want to test the dwell inside, dwell outside, we can use the scenarios widget to actually trigger that. You define the routes, the Wi-Fi hotspots, and then the no GPS zones. So we can actually have that radius, and you can see the UI is clear enough, easy to use to achieve this purpose. Okay, so that brings us to the end of this session. We've looked at location services, and more importantly, we've looked at how WorkLight allows us to use location services to make our applications more robust and more interesting. We've saw the architecture of location services as used in WorkLight. We know what the acquisition policies are. We've talked about the triggers and events, and finally we have seen how to test hybrid applications which have employed the location services. Thank you, and see you in the next session.